Hey guys, if you're planning to take the December 2024 SAT, we have a new problem set out to help you better understand the types of problems that you could see for the new digital SAT. Before we get started, I want you to note the disclaimer listed above and also take a look at the problem listed here. Pause the video in just a second to review the problem and try to attempt to solve the problem yourself. Once you're done, make sure to unpause the video and we'll review together. Okay, now that you're done potentially answering the question, let's try to tackle this problem together to try to see if we can essentially solve this problem in a way that could be easier. I just want to note for the new digital SAT, we are in the 1-year process of the test being released, which means that now the testing company understands essentially how students answer questions. And the benefits of utilizing Desmos means that we are seeing more problems that are being released. And those problems mean that you're focusing less on the efficiency of Desmos, meaning that you could have problems that you can use Desmos, but it might not be best suited for you based on the fact that you could actually solve it more efficiently if you don't utilize Desmos. And this is a sample problem of that. Let me explain. So they talk about the weight of different gemstones in a jewelry store, and they list a bunch of numbers here. I want you to note that this is an even number of values. So if you see here, you have 3 times 1, 2, 3, 4, 5, 6, which means that you have essentially 18 values. And I point this out as a fast way to, instead of going 1, 2, 3, 4, 5, 6, they don't really tell you the total number of gemstones that are provided, but you're going to know when they give you like a box like this, they're letting you know that you can calculate the values essentially faster by letting you know that, okay, it's a 3 by 6, you times them together, and you can essentially see how many total gemstones or different types of gemstones there are without even counting. So that's a fast trick to help you solve. So we now know that there are 18 gemstones based on this information. They want you to compare mode, mean, range, and median based on the following question, which basically says if the lowest weight, 1 gram, and the highest weight, 18 grams, are now removed, they're asking you to figure out which measures of central tendency or dispersion would change the most. Now, I want to review what mean, median, mode, and range are, but before we get started, I want to note that on Desmos, you can manually type all these numbers in and compare with and without 18. But you can see here there are 18 values, which means that you essentially are typing this 18 times 2 times. 18 times, and then with removing the 2 additional values, the 1 and the 18, you drop it down 2 gemstones, which means that it's now 16. So you're comparing 18 values to 16 values, and typing that alone could take some time. I know you could copy and paste, but it can take some time. Even if you have a graphing calculator and you could figure out a way to copy and paste, even typing in 18 values all the time can be cumbersome. So we're going to try to see if we could solve this faster. So let's first go over what these words mean. Starting with median. Median sounds like the word middle, and median is essentially that. What are the middle numbers here? When we're talking about range, we're talking about the highest minus the lowest value, and that is essentially the highest in the group minus the lowest in the group. Mean, the way I like to think of it, is if you're mean, you're just average. And so the mean is your average number, and mode is your most often used number in a set. So MO, you could see O often. That's how I like to remember it. So let's take a look at mode first. You could see here they're asking you to compare what the mode is, or the most often used number in the series. And there's 2 essentially. There's a 3 that is repeated twice and a 10 that's repeated twice. Just so you're aware, if you're taking the 3 and the 10, which are the most valued numbers, because there's 2 3s and 2 10s, and even if we remove the 1 and the 18, it's still going to remain the same. The most often used number in both sets are still going to be 10 and 3. So because of this, we didn't really change anything with that dispersion when we changed the values from 18 to 16 by removing these 2 digits. And because of this, we can essentially say the mode is not going to be the one that's going to change the most. It really didn't change at all. So we say 0. So now let's take a look at the mean. The mean can be difficult to calculate. For this one, you're going to have to calculate essentially the total value of the sum. So the first thing that we can say for the current total, if you did plug this into your calculator, you would go ahead and plug in all these values here and you would add them together. I know it's not all on the screen there, but essentially you would type them all in, all these values, and take the sum. So you would take 1 plus 2 plus 3 plus 3 plus 4 plus 5 and keep going all the way to the very end and divide it by the total number of the values themselves. So what I mean by that is if we add all these numbers in, plug it into your calculator, so 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, and I keep going all the way to 18. I essentially will get 156 and then go ahead and divide that by 18 to essentially figure out that is going to be 8.67. So that's the first value of your mean for B. Now, if I were to remove these two numbers, 1 and 18, add them all up and divide by the new total, which is 16, you could do that, or you could say 156 minus 18 and 1. So 156 minus 1 plus 18. And you would essentially divide that by 16 because that's your new value. Type that into your calculator and you get 8.56. Now, I did manually calculate this value just to show you that you can calculate it out. But hypothetically, I want you to think of this in a big ticket scenario. You have a bunch of values of different types of gemstones in grams, and you're taking the highest and the lowest number out. So they're extremes, but they're not too off from the majority of numbers of here. There are a series of numbers. They're not too far away from one. Essentially, 1 is not too far away from 2, and 16 is not too far away from 18. So the mean itself and the difference is only decimal places away from each other. I want you to keep that in mind when you're solving a new type of problem that asks you something like this, where you have to calculate the mean. Because the thing is, now you know if I don't have enough time, I can hypothetically think to myself, if I'm only taking away two numbers, and unless one number is extremely off, is the value really or the average going to change by that much? Not really. So I want you to think to yourself, if you had a series of grades, A, and then you had a B on a report card. And then you said you're going to take away one of the A's. So now you have A, and B. Did the average really change between the two? You're still an A student overall, even if you had the A or didn't have that one A. You're still overall on majority an A student. And that's the same way you want to think about it here. Taking those minute numbers is not significantly going to change the value from 18 to 16. It only goes by point something decimal place. And I want you to keep that in mind if you are really solving this problem on the exam. Because if you are, you could actually estimate that this is not going to change that much rather than calculating it like we did. I just did that to show you. Now let's take a look at something like the range. So the range is the highest minus the lowest number. This is a little bit easier to calculate because you have 18 minus 1 when you have the 18 and 1 there, which is going to be 17. And you have the change in range from now 16 and 2. And that's going to be, now you have 14. So you could see here, 17 minus 14 is 3 spaces. There's 3 whole number difference. So this is way more significant than these decimal places. They're whole numbers. They really move the needle in terms of the differences in dispersion, because you're literally taking the highest of the highest minus the lowest of the lowest. It's like saying that you bought a house for $100,000 versus $1. That range is so significant. Versus a mean, you could have a $1, another $1, 15 $1, and then $100,000. You take away the $100,000, maybe if it's one value, that's an outlier. But if you had $1, $1, $1, like if I said I was doing a mean $1 house and then maybe a $2 house, taking away that two isn't really going to significantly change the mean, the average, essentially, because the average is taking all the numbers and essentially finding a middle ground between them. Versus the range is taking a look at the extremes and seeing the difference. So because of this, B can be eliminated. Now, if we take a look at the median, so the median is going to be the middle two numbers. Now we have 18 numbers and 16 numbers, which means that they're even, which essentially means that the median is going to be the middle two numbers divided by 2. Taking a look at the fact that these are in numerical order from least to greatest, and the fact that we have 1 and 18 that are included, if we go ahead and just think 18 divided by 2, is going to be 9. We're looking at the ninth middle number, give or take. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now remember, we're looking at the middle two numbers. So we're looking between 8 and 9 for including the 18 digits. Now, if I have 16, looking at the 16 divided by 2, that's going to be, now we have 8 that we're taking a look at. So 1 without the 1 and the 18. So 1, 2, 3, 4, 5, 6, 7, 8. Now you could see here the middle two numbers are still the same. So we really didn't change anything because the middle will remain the middle. It would be like if you had a candy bar and if you said to yourself, hey, I want you to figure out the middle of the candy bar, but I want you to chop off and eat both sides. The middle still remains the same, no matter if you chop both sides, as long as it's even. So because of this, the median will remain the same. So our best answer choice is the range. So yes, you can calculate using Desmos, utilizing the tools that are given in Desmos or your graphing calculator to solve mean, median, mode, and range. However, you can hypothetically theorize that the mode is going to be the most often used number. That will stay the same as long as it's not the highest and the lowest number. The mean is going to be very similar as long as there's no extreme numbers. The range is going to vary because you're literally taking the extremes and separating them. And the median, which is the middle number, if it is even numbers, meaning we had 18 and 16, they're not really going to change because it's like that candy bar scenario. So I hope this helps you better understand the ways that you'd solve problems a little bit quicker without utilizing Desmos. Hope that if you see a problem just like this, you will be a-okay. And now you can see that even though we calculated a bunch of things out, you don't need to for the actual exam if given a problem like this. So make sure to take this as a special note. Make sure to hit that like button, subscribe, because we hope to see you soon for more videos just like this to make sure that you score the best score that you possibly can. Thank you so much. Also, before I forget, if you're looking for more videos like this, make sure to go through our playlist. We have an SAT playlist and we have a ton of videos with a ton of different problems. And we hope that you view them before you take your next exam because they truly are helpful at getting you to your best score.
Hey, Geeking Out on STEM family, guess what? We want you to hit that subscribe button. Why? Because we'll be producing more content just like this for the AP Biology exam and the new digital SAT exam. By subscribing, you'll be getting exclusive up-to-date tips, tricks, and secrets for both exams. Also, if you're a parent, a teacher, a homeschool instructor, or a student, you might be looking for affordable and exclusive digital products to help improve multiple choice questions, free response questions, or question bank questions related to both the digital SAT or AP Biology exam. We have them here. Make sure to check out our link tree in our bio for curated resources that you won't find anywhere else. These unique resources are designed to help you raise your score. By hitting the subscribe button, the more subscribers we get, by the way, the more videos we can make. So make sure to join our family to ensure that you get a perfect score for both exams. We